Hello everyone, this is Dr. Sulaiman Khan and you are watching my YouTube channel The Beauty of Mathematics. Today I would like to talk about the recurrence relation of the Legendre polynomials. The relation of this type n plus 1 time a Legendre polynomial of n plus 1 degree is equal to 2n plus 1 time x Legendre polynomial of degree n minus n time Legendre polynomial of degree n minus 1, where n is equal to 1, 2, 3 and up to so on, and Pn are called the Legendre polynomials of degree n, and this relation is called the recursion relation of the Legendre polynomial. So we have to prove this relation by using the generating function of the Legendre polynomials, which are defined by 1 divided by 1 minus 2x u plus u square whole square root, which is equal to summation n is equal to infinity Pn x u power n. So first of all we have to differentiate the left hand side and the right hand side with respect to u. So we can get, while differentiating this, its power is, if we write it is in the form of 1 minus x u plus u square whole power minus 1 by 2. So we can differentiate this term's differential. So this can be written as 1 minus 2x u plus u square power minus 1 by 2. So while using the power rule, it can be written as minus 1 by 2, and this is the whole expression, the same expression, and its power will be minus 1 by 2 minus 1, which will be equal to minus 3 by 2, and further derivative of this expression, which will be minus 2u, and this expression with respect to u is minus 2u, and this one is plus 2u. So this can be written as minus 2u plus minus 2u x plus 2u. So we can take 2 common over here, minus 2 common, this minus 2 plus, and this minus 2 will be cancelled, and this expression would be this one whole expression, and its power is minus 3 by 2, and here we can write u minus here it will be we have taken minus common, so it will be x minus u over here. So we got this while taking the derivative of this expression. And similarly on the right side we have taken derivative of u n with respect to n, which is n time u power n minus 1. So now we have to we simplify this x minus u, and we split this into the product of two expression, like this expression we have taken this one, and how we get this one. So we can write it as in x minus u time 1 minus 2x u plus u square. This is a plus 3 by 2. When we take it to the numerator, it will be minus 3 by 2. So it can be written as minus 1 by 2 and 1 minus 2x u plus u square power minus 1. When we multiplying these two, so the power can be added, and we can get again minus 3 by 2, which is this one. So now this expression is changed to the right side, and the left side is this one, and the right side has changed to the 1 minus 2x u plus u square multiplied with this summation. We have expanded this for n is equal to 1, so it will p1, and for n is equal to 2, it will be 2 times p2 u power 1, and so on. So we have expanded this. Next, we will we have simplified this expression, this one, while using some expansion of the binomial expansion. So x minus 1, and this one is taking 1 plus n. The value of n is 1 by 2, minus 1 by 2. So we have used the negative into negative is positive. This is the value of x, and so on. We have expanded this up to the other terms as well. So on the right hand side we have written the same expression, and here now we have get this simplification when x is multiplied with 1. So we have got x when x is multiplied with this expression, this 2 and 2 will be cancelled, and x will be x square u. So this is x square, this is u, and when x is multiplied with this expression, so we can get minus 1 by 2 x u square. This is u square, minus 1 by 2 x is over here. And similarly by the same way, and when minus u is multiplied with 1, so we have got minus u, which is this one we have taken here. When minus u is multiplied with this one, this will be minus u square, 2 and 2 will be cancelled along with x, so minus x u square. And similarly with the same expression, same technique, we have got this one. And here we have multiplied this p1 with 1, which is p1 multiplied with this one, so we have got minus 2x p1 minus 2x p1, and u we have taken common. When we multiply 2 p1 with u square, so this is u square, we have taken common, this is p1. And similarly when we multiply 2p2 with the 1, so we have got this one. There is only u common, which is this one. When we multiply this with this second one, we can get minus 4x u square. So minus 4x and u square is this one, and p2 is this one. And similarly for the rest of the series. So now we have to compare the coefficients of the power of u on both sides. So we have started it from here, x, next is u1, u square, u cube, and so on. And similarly on the right side, u1, u2, and so on. But here is u0, and here is also u0 with this p1. So for the u0 or u power 0, p1 is equal to x, and for the u1, this is u1, x square minus 1 is equal to 2p2 minus 2x p1, this one. So which we have taken this one over here to the right side, and this can further be simplified, 2x p1, where x square can be written as x into x, while in place of x we have put p1 and minus 1. And as we know that Legendre polynomial of 0 degree is 1, so we have replaced this as p0, and this is added. So 3x p1 minus p0 is equal to 2 times p2x. And similarly for u2, u square, so this is the one expression, and this one is the another expression while comparing both the sides. So we have got this can further be simplified, shift this numbers to this polynomials to the right side, and we have taken x by 2 common from these two, and we have got x by 2, this one, minus x over here, so 4x p2 minus p1 plus x time p2. How we got this p2? We can get it from here, because this can be simplified. This is 3x, and the value of p1 is what? P1 is x, so this can be x square, and p naught is 1. So while dividing on both sides, so p2 can be written as 3x square minus 1 by 2. So this is the value of p2. So 3x square minus 1 by 2, which is p2, and x is p1, so this one. In short, we can simplify this 4x and x p2, which is 5x p2 minus 2 time minus p1x minus p1x, which is minus 2 time p1. So similarly, we can write for the u cube 4p4x is equal to 7x p3 minus 3 times p2x, and for u4 we can write 5p5x 9x p4x minus 4 times p3x. So this can be written as 4 plus 1, this 5, and this p5 can be written as p4 plus 1x, and this 9 can be written as 2 into 4 plus 1 x p4x minus 4 times p4 minus 1. This 3 can be written as 4 minus 1 x. So for u4 we have written this technique, this formula in this form, and when we generalize this we have, when n is equal to 4, so we can replace in place of 4 n plus 1, p in place of 4 we have written n, so n plus 1x equal to 2. 2 times 4 means 2n plus 1 x, so it is, here is x, we have forgotten, this is x, and p4 in place of 4 we have written n, and again in place of 4 is n, and 4 n minus 1x. So this is the general formula. We can generalize this technique, and this is called the recursion relation of the Legendre polynomials. So this is all about the recursion relation of the Legendre polynomials. Thank you so much. See you next time.